You're listening to ReachMD, and this is Lipid Illumination, sponsored by the National Lipid Association. I'm Dr. Alan Brown, your host, and joining me today is Dr. Marc Hamilton, professor at Pennington Biomedical in Baton Rouge, Louisiana. Our conversation today will focus on the cardiometabolic consequences of sitting time. So, Dr. Hamilton, thank you very much for joining us today.
It's nice to be here. Thank you.
So, we've all been hearing for years about the importance of exercise, and yet most people sit and watch TV for the vast majority of their time. And I'm really interested in hearing what the results of your research are on the consequences of sitting time, and particularly how much sitting is a problem. So maybe you can tell us a little bit about what you have learned with regard to sitting time.
Right. Well, we've really just begun to scratch the surface with regards to what happens during all this inactivity that we fill our days up with. And you're right, that most of the time the inactivity we have is sitting. And really for about a decade, our lab was focusing on exercise and what are some of the healthy effects of it. And while there's no doubt that exercise has many good effects for people, it's not a panacea. It's not the fountain of youth, even though it's incredibly good for people. And what we saw was that specifically for some of the risk factors for disease, some of the more potent mechanisms that we really wanted to hopefully untap with exercise, they were unaffected. And in the course of our research, what we learned to our surprise was that some of the most potent mechanisms in the body that regulate health, especially through lipid metabolism, are more affected by low-intensity activity when dispersed throughout the day than a big shot of exercise at the end of the day, say 30 minutes or 60 minutes of exercise.
So give us some examples then of what you mean by more low-intensity exercise during the day, and tell us a little bit about what's the healthy amount of walking or moving around that you recommend.
Sure. Well, the types of activity we're talking about are generally the things that we're already doing when we're up on our feet. The light activity that we might spend cleaning the kitchen or getting ready in the morning for work. And most people don't think of that as physical activity. And in fact, the scholars have not thought of it as physical activity. In fact, by definition, the leading governmental agencies and all the exercise experts have explicitly said that that's not healthy activity. And the reason is not so much that they know it's unhealthy, but rather it was something that was just unstudied in the past. And so they knew that brisk exercise, where you break a sweat, and you get your heart rate pounding and your ventilation increased noticeably, they knew that had some good effects for people. But you have to remember that activity is rather brief over the course of the whole day, whereas this low-intensity physical activity, and we use the acronym in our lab, LIPA, L-I-P-A, that this LIPA-type activity accounts for about 6 hours per day in the average American. That's a lot of time that your muscles are actually contracting, obviously far more than you could ever do by exercise. One of the really nice things about this type of activity is it's very achievable. Like I said, it's something we're already doing, but people are just not cognizant of the fact that it's good for us, and that when the muscles are working intermittently throughout the day, it has some very large physiological effects on people's health.
So, yeah, that's fascinating. I often think, since you and I both take limos to the airport, and I think about the limo driver who basically is sitting all day long,
right,
driving people around. And
that's
then
right.
At least we have to get up and walk around on rounds, so we do a lot of walking. That's
actually a curious point you bring up, because when our lab started doing this, it was about in the late 1990s. We were studying rats. And it wasn't really until 3 or 4 years later that we began to more explicitly say what we thought the implications of the findings were. And we thought it had some strong implications for human health. At the time, we weren't testing this in people like we are now. And so what we did is we just went and looked and scoured the literature and saw that, ironically, the very first study that really sparked the research revolution was from data that was collected in men who sat to drive all day long. It was actually done in England, and they were studying bus drivers and subway conductors and subway drivers. And what they saw that the conductors, who by virtue of having to be up on their feet their entire shift, actually were more active than the drivers, and that goes without saying. But that what was remarkable in this study, they weren't looking for this, by the way. They were looking at a different question. But what they found was that the rate of death from heart attack in middle age was twice as great in the drivers of the buses, or the drivers of the subway trains, than the conductors. And that really got the scientists who performed the research interested in this. And he also looked at other vocations, as well as in the postal clerks versus the postal mail delivery folks. They looked at other kinds of jobs, and what they saw time and time again were that those people who had to sit to work literally dying of heart attack at twice the rate as the others. And the beautiful thing about those studies is that while they weren't interpreted in terms of the paradigm that I'm describing to you, but the beautiful thing about it was that the data, though, was rather raw and pristine. Because nowadays, folks who go to the gym and get all hot and sweaty for an hour a day, and that's a good thing to do, but that's a different breed of individual. We all know that those people are more likely to watch what they eat. They're more likely to listen to their physician and take their medicines. They're more likely to take their vitamins and so on. Whereas back in the 1940s and early 50s, people didn't even, in fact, physicians didn't even agree whether exercise was a healthy behavior. And so this was a rather pristine kind of observational experiment that they performed.
Well, I remember Winston Churchill once said that the only exercise he got was being a pallbearer for his friends who exercised.
Well, if you look historically, it is interesting that there have been a number of noted individuals who just, like, maybe it was self-evident to them, but they described what is a healthy lifestyle. And it really wasn't until, let's say, the 1970s when the aerobics concept came to be. And that whole idea came out of how to exercise train for sports. And so that the first recommendations by leading organizations like American Heart and so on how to exercise essentially described how athletes train, how endurance-trained runners run or swimmers swim. It really wasn't well designed for the masses of people who might be either aging, have a bad knee, a bad back, might be obese. These individuals are oftentimes find it very uncomfortable to exercise like an athlete. And that's why the rates of sedentary living are so high these days, is that people become discouraged when they're told to do something that they don't like to do. And we and others have tried to quantify how many people actually do the minimum recommendation of 30 minutes on 5 days a week. And the numbers are shocking when you look at how few people actually do exercise.
If you're just tuning in, you're listening to ReachMD. I'm Dr. Alan Brown, your host, and joining me today is Marc Hamilton. We're speaking about the cardiometabolic consequences of sitting time. So, Marc, let's talk about a couple other issues then with this. Number one, I'd love to hear you talk a little bit about the pathophysiology and what happens to people who are very sedentary and sit a lot. And then we'll finish with what your recommendations would be if you were going to tell the average person out there who's not vigorously exercising what to do. So can you tell us what you've learned about the pathophysiology and what happens when people sit?
Sure. I'll give you a couple specific examples so it really is more tangible. One is with the principal enzyme in the body that gets rid of the fat that's in your blood. And that we know from literally hundreds of studies that there's really a single enzyme that lines the blood vessels of your body that is essentially the vacuum cleaner for fat in your bloodstream. And that enzyme is called lipoprotein lipase, and it's abbreviated LPL. And we know that people who have genetic problems with LPL have very high levels of fat in their blood. They also have very low HDL good cholesterol. So this enzyme, the reason I say it's like the vacuum cleaner for fat in the blood is that it very effectively can grab onto the circulating lipoprotein, and it can hold them and then bust them apart like a little drill. And that then the fatty acids, the fat that comes out of that lipoprotein, is then largely taken up by the underlying tissue, wherever those blood vessels happen to be. So in the case of skeletal muscles in the legs that are utilized when we are not sitting, that those muscles can be very enriched in this enzyme, LPL. And so essentially your legs are using this fat as a fuel, and it's keeping the debris out of your arteries and keeps it from being stored in adipose tissue. So we know that that enzyme is very important for good health for a lot of reasons. Well, when we were studying this, we said, what is it that turns on this LPL activity maximally in the legs? And again, we tried exercise training. We tried all kinds of exercise training in rats. We tried it in humans in a couple studies. And what we saw was that was really not a good stimulus for turning on this LPL. But what we noticed was that the dark red muscles, essentially what you would call dark meat, we call oxidative muscles. These are the muscles they're highly energized with pathways for burning up fat. That those muscles were very, very enriched with LPL, literally 1,000% more LPL in that kind of muscle than the white muscle, the glycolytic muscle, which is the muscle that relies more off of glucose for fuel. And so we said that what we really need to figure out is why is it that this red oxidative muscle is so enriched with this healthy enzyme? And so we first performed an experiment where we took rats and we simply minimized the amount of time that they stood in their cage. We didn't change their exercise habits at all because none of these animals exercised. We just minimized the time they were on their feet in their cage. And we actually did it where we could make one leg inactive or two legs out of four legs inactive and so on. And what we saw was that whatever leg we made inactive lost this LPL enzyme level virtually completely within a very short amount of time. In fact, even in the first day of rendering them less mobile. And so we're talking about a 10-fold change in the amount of this enzyme. And that was very surprising to us and other people who are studying lipids because there are no pharmaceutical approaches and there are no nutritional approaches. And like I said, exercise doesn't do it either. To change the enzyme this much. It's not to say that some drugs can't have some effect, and some nutritional changes can have some effect. Usually that's in the order of a 20 or 30% change, and it's considered meaningful. So when we saw 1,000% change, that we knew that we really hit on the key factor. We followed that up with many other studies to show why that happened specifically. And since this whole new scientific discipline that we coined inactivity physiology or inactivity science, which has just really exploded in the last 5 years. And so now we have wonderful scientists from all over the globe looking at it. We have now literally over 100 epidemiological studies looking at hundreds of thousands of people with all kinds of risk factors for disease as well as mortality. Some cancers seem to be particularly affected. Certainly there are processes relating to coagulation and blood clotting. That's another fascinating story that we recently published a paper on.
Let me see if I've got this right then. So even if you go out and exercise for 30 minutes, what's more important to your health is how much time are you sitting when you're not exercising. So it's actually the amount of time sitting is probably the bigger detriment, even if you do bursts of exercise.
Right. There's certainly independent effects. And the effect is perhaps bigger in many cases simply because we look at time. We look at time in the whole body, in that our body is constantly, all the cells are constantly sensing their environment. And we can't do anything about that. We can't shield them and turn them off. And so the cells in our bodies, they sense when we're inactive. And so if we're inactive 23 and a half hours a day and we get up and we jog for 30 minutes, yeah, that 30 minutes is going to help. But it's also going to sense this much larger background of inactivity over the whole day. So we've actually performed studies where we've taken individuals, both humans and rats, and we've exercised them hard for an hour a day, and we said, can that counteract the effects of sitting too much? And for some of these processes that determine serious diseases, it does not have exercise is not the perfect antidote to all this sitting.
Well, I really appreciate the insight into the research that you're doing. The idea that who knows, maybe we can tap our feet and do some leg exercises in our chair, and maybe that'll reduce our risk for myocardial infarction. I can't wait to hear the results of your final research, but it's certainly intriguing. Unfortunately, we've come to the conclusion of the program and run out of time, but Dr. Hamilton, thank you so much for being with us today.
You're welcome.
I'm Dr. Alan Brown. You've been listening to Lipid Illumination, sponsored by the National Lipid Association. I'm ReachMD. Be sure to visit our website at reachmd.com/lipids, featuring podcasts of this and other series. And thank you for listening.